So we have two more talks in our session today. Our next speaker is Caroline Juang from Colombia and Lamont, and she is here in person, and she will be speaking about the question of how sensitive is future Western U.S. wildfire activity to uncertainty in ENSO. So lots of ENSO today. It's been great to hear.
All right. Yeah, thanks for having me today. My name is Caroline Juang. I'm a PhD student out at Columbia University, and my co-authors for this talk are Dr. Park Williams and Dr. Richard Seeger. So to start off the story with the Western US wildfire burned area, we can take all the forested area in the Western US and put it on an annual scale to see that forest fire area burns from 1984 to 2021 has increased over time and in a pretty large magnitude of over 1,000% in that trend. And this is due if you put the trend line on a log burned area. So knowing this forest fire area burns, we know that this is largely from a drying trend in the southwestern US. So we want to know what is the drivers of that burned area or that climate over the western United States. So we can turn to see whether the El Niño-Southern Oscillation or ENSO is part of that driver. And we know that that ENSO in general is this gradient between the western warm pool of the tropical Pacific Ocean and the eastern cooler waters of the tropical Pacific Ocean. And when we take that difference, we can get the ENSO trend over time. And that gradient actually relates to climate over the western US, in this case in a dipole effect, where the northern Pacific or northern western United States has a wetter trend and as the gradient is stronger, and the southwestern United States has a drier trend when the gradient is stronger. And overall, from 1984 to 2021, this gradient has been enhanced, where we're experiencing a more La Nina-like state over time. So the question for this talk is, what is the influence of that strengthened SST gradient, and how does that affect the Western US wildfire story? So in order to answer this question, we can build a two-part model to predict Western US area burns. The first part of the model takes into account this ENSO, or this sea surface temperature gradient, and in order to predict climate variables over the Western United States. These variables that we chosen here are attributed to annual area burns, and they're all predictors of annual area burns. And the second part of the model inputs some of these climate variables depending on a stepwise linear regression model in order to predict annual area burns across the entire Western United States, or just within the ecoregions, which is ecoregions level 2 from the EPA. And so that's that model. So if we combine these two models, we can use observed sea surface temperature, that gradient between the Western Pacific and the Eastern Pacific Ocean, in order to predict annual area burns. When using this model and looking at the results, what we find is that if we just take the second part of the model just to look at how climate is predicting Western US forest fire area burns, we can see that there is a very close attribution where climate predicts 92% of that burned area trend over the entire Western United States. Meanwhile, sea surface temperature gradient, or ENSO, does have a trend and contributes positively to this trend with 13% explainable of this trend. And you can't really tell from the blue line here, but that blue line is increasing positively, and that's seen very well with the jump in the predicted burned area from post-2000 compared to pre-2000. And that's actually the jump from a more ENSO-like state in the sea surface temperature gradient to a more El Nino state to a more La Nina state, which is that attributed to that drying trend over the Western United States. So the next question, using this model that we can see that we can attribute sea surface temperature gradient to Western US wildfires, the next question is an exercise of what if the last 40 years had seen a trend towards a reduced SST gradient trend instead of the observed increased SST gradient trend. And the reasoning for this is because in a lot of state-of-the-art climate models, such as CMIP-5 and CMIP-6, these models actually do not replicate the observed increasing SST gradient trend. In fact, they instead see a weakened trend towards a more El Nino-like state, which is a flipped state of what we are currently seeing. So we can instead do this exercise where we take the SST gradient trends that's observed and flip that in order to keep the variability, the interannual variability of it, but attach a negative trend to that sea surface temperature gradient. And when we put this back into our model, what we find is that across the board, even with northwestern ecoregions and southwestern ecoregions, the overall burned area trend is decreasing because of this El Nino-like trend that we've done in this exercise. And this makes sense in the southwest ecoregions, where originally we were seeing a drying trend and increased burned area because of that drying trend. If we put a wetting trend because of the reduced sea surface temperature gradients, we would instead see less fires. But this is surprising in the Northwest Pacific, where we should go from a wetter trend to a drier trend over the climate variables, and should see more fire, but rather instead we see less fire. And this is the difference between the blue line here showing from the observed SST gradients to the orange line showing the negatively trended SST gradients. And overall, these two lines between the blue and the orange show that if we have this change in the SST gradient trend, or that ENSO trend, we're experiencing a 10% decrease in burned area from that SST gradient contributed trends to burned area across the Western United States. And if we look at this spatially, then we see that the strengthening SST gradients has overall increased or overall contributed positively to all parts of the Western United States. And that's shown in the figure on the right, where we have the change in the ENSO contributed burned area trend across these different level 2 ecoregions. This trend is very significant, especially in the southwestern United States. And that makes sense because ENSO is closely tied with climate over the southwestern United States. Overall, though, the ENSO trend in burned area, or the ENSO contribution in burned area, is not the most important contributor to the burned area trend that we're seeing. And so other effects may be the anthropogenic climate change and whatever else is contributing to climate over the Western United States. But it does show that this is a part of that trend and part of that sensitivity of burned area, possibly now and into the future. So just to wrap up my slides, so we found from the models that climate can strongly predict variability in Western US forest fire area, and the internal variability of the sea surface temperature gradient, or that internal variability of the ocean and ENSO, has weakly contributed to forest fire area by a magnitude of maybe 13% of that trend. And finally, by looking at our model and across all ecoregions, the strengthening SST gradient has contributed small but positively to the overall burned area trends by a magnitude of 10% when we compare the SST gradient and its enhanced trend versus the decreasing trend if we were in that flipped El Nino-like state. So thank you very much, and looking forward to questions and feedback.
Excellent. Thank you so much, Caroline. Do we have questions? Go ahead.
Really interesting talk. And my question may come across as being a little pedestrian, but here it goes. My appreciation of forest fires, and at least in terms of attribution, it's an incredibly complex thing to do. And one thing that strikes me is that a lot of forest fires are human ignited. They're ignited by human causes. So I'm curious if there's some way that you can focus or if you thought about focusing your analysis on only naturally occurring or forest fires that are caused by natural events, or maybe you've already done that. Just curious to know.
Yeah, so that's a great question, because I know that in the Western United States, about 50% of the fires are lightning caused and the other 50% are human caused. With the database that we're working with, there isn't much information on which is the causes. But then at the same time, I think with looking at these long-term scales, what's also important is the climate involved with it, because it determines more about the burned area spread rather than like the initial conditions. But I think it is a factor to look into. Thank you.
From the the perspective of our lighthouse activity, I think it's really nice that you're working on distinguishing the long-term trends from these modes of variability, because I think that's a really important overall objective of our lighthouse, is to be able to distinguish these features, particularly if we want to think about how they couple together in future. So thank you for that.
Thank you.